Everybody, this is quiz number 1 for your intermediate algebra class. Quiz number 1 serves as your practice exam for your real exam. Now, what I'm going through with my quiz number 1, the numbers might be slightly different than the numbers that you're getting for your quiz number 1, which would be slightly different than the exam questions as well. So hopefully this will help you to get through that. So our first question is here. And obviously I'm going to be using the distributive property. So I distribute the negative. Now that's going to change both signs here. Notice that's a plus 12 now. I'm going to combine up my like terms here. Now notice I'm not moving things across the equation yet. I want to combine up my like terms on each side first before I start trying to combine up anything. Now I'm going to move the 4x over to here. Now if I get a fraction as an answer, that's okay too. Again, I'm getting rid of the 7 here. That is going to give me 31. Giving me that x is equal to negative 31 over 7. All right. Problem 2. Right, here we have some fractions. And what I'm going to want to do here is multiply through by the common denominator. Now I have to look at the denominators here. I have 3, and I have 5. It looks like that's going to give me an LCD of 15. Now, I also want to point out here, this is plus a negative. That becomes subtract. So I'm going to multiply both sides of the equation through by 15. And that means that everybody gets a 15 multiplied to it. Notice that's minus now. I made that subtraction now. All right, I want to show you a little trick here. What I can do to get rid of these fractions is, remember that's 15 over 1. So what I can do is I can actually, 15 divided by 3 is 5. 5 times 7 is 35. I'm going to do the same trick here. 15 divided by 3 is 5 again. 5 times 5 is 25. 15 times 9 gives me a negative. A positive times a negative is 135. And I'm going to use that trick again. 15 divided by 5 is 3. 3 times 8 is 24. These numbers are getting pretty big pretty quickly. Notice I can't combine up any terms on either side. So I'm going to move that because it's minus 24. I'm going to add a 24K. And that gives me a 59K. Now I'm going to add a 25 to get rid of that. That it gives me 160. And now I'm going to divide both sides by 59. Here's my answer for number 2. A little bit of bleed through because these pens are so bold, but that's okay. We should be all right. All right, next up we have number 3. So here we're dealing with some decimals. Now some teachers teach where you multiply everything through by 100. You could do that, that's not wrong. I'm just going to keep everything as is. And I'm just going to distribute the 0.25 as well as the negative 0.09. I think that's going to be 15. Let's see, 0.25 times 60. It's 15. Minus 0.09. Please note I'm distributing a negative here. That makes that negative times a negative gives me plus. Gives me 2.7. Here, I need to combine up my like terms on each side first. So 0.25x minus 0.09x is 0.16x plus 15 plus 2.7 is 17.7. Next up, I'm going to subtract 17.7 to both sides. And what I'm going to do on this is I'm going to get rid of the decimals when I divide, and I'm going to actually multiply by 100 to the top and bottom. that is going to give me negative 320 over 16. Which means x is now equal to a negative 20. You divide that out. Number 4. Here we have a formula. And we want to solve for a. Meaning I want to get that a by itself. First thing I'm going to do is just distribute that 4. Just to let you know, there are several ways that you could do this. You could divide the 4 out first and so on. I'm just going to distribute the 4, and students tend to see that more often at the beginning. And I'm just going to dig that a out like I would any other linear equation like that. I'm going to subtract off the 8b. Please note y and b are different variables, so they can't combine. Next up, I'm going to divide by 12. So we're going to save us some space here a little bit. That's going to give us that a is equal to y minus 8b over 12. A very, very common mistake is students try to reduce that 8 and 12. That is very inappropriate. You can't do that because we're adding and subtracting in between. So that's not a good idea. All right. So if we can squeeze 5 in here, I think we can. 5, we have an inequality. All right, big thing to remember with these is if I ever have to multiply or divide by a negative, automatically, the direction of the inequality switches. I'm going to go ahead and subtract a 2x to both sides. Notice I subtracted, that's not multiplying or dividing. Next up, I'm going to subtract an 18 to both sides. Finally, notice here I am dividing both sides by a negative. So that is going to go from a less than to a greater than or equal to. Now I want to answer this using both interval notation as well as the graph. Try to squeeze that here. Actually, I can put that here. So the interval notation, to show that I'm including the 2, I'm going to use a closed bracket like that. And bigger than is going to go off to positive infinity. So there's interval notation. And if they ask for the graph, once again, to show that I'm including the 2, it's going to be a closed circle. And positive infinity is that way. All right. Control screen, we are. So we are moving on to another problem, number 6. Here we have an and or situation. So I'm now going to solve each of these linear inequalities and then try to figure out what and means. I'm going to start with this left one. I'm going to add an 8x to both sides. Now, I want to be clear here. What I'm going to do next is divide by 14. Now, I know there's a negative over here. I'm not dividing by a negative 14. I'm dividing by a positive 14. So that inequality will not switch. It's only when the denominator is negative. So if x is bigger than negative 1, and now I'm going to solve this linear inequality. Adding 1 to get rid of that. Notice again, I'm dividing by a positive 15, so the direction of the inequality is not changing. Now, they want both a graph of this. Remember, this is all and. They also want the interval notation. So I'm going to do a graph. This is not the final answer graph, but I do want to show you what this means. So this is saying, and I'm going to use bigger than negative 1. So here's open circle, and bigger than is this way. Also, so this is my red. For x is less than or equal to 2, that means I'm going to have a solid circle. This is my purple. Is there. Now the and is just where there's overlap, meaning this condition and this condition at the same time has to be true. So I need only numbers that are bigger than negative 1 and at the same time less than or equal to 2. That's going to be in the middle here. That's where the overlap is. Not including this endpoint, but including this endpoint. So here's what the real graph is going to look like for the answer. There. And the interval notation is going to be so this bottom one is the actual graph. Now you'll note I'm not including negative 1, but I am including 2. 2 is on both. 2 is bigger than negative 1, and it's less than or equal to 2. All right, we are getting there. So here we have what's called a compound inequality. And this one asks for both notations as well, the graph notation as well as the interval notation. Now, if you remember, I'm trying to get x by itself in the middle here. So I need to add a 2, but I need to do it to all 3 places. All right, now you'll note what I need to do next to get x by itself in the middle there is divide by a -3. Be careful, it's a -3. That means all the inequalities are going to switch. And the way we write that, we don't like it with the greater than, we want it the less than less than. So what I'm going to do is I'm going to actually pick this up and flip it upside down, which is going to make it look like this. Now you'll notice the open mouth for this one is at the 4. The open mouth for this one is also at the 4. The open mouth for this one is at the x. The open mouth for this one is also at the x. So these are equivalent statements here, but we need it this way so that when we write it in interval notation, we don't confuse which one goes first. Notice I'm not including the -3, but I am including the 4. This graph will look like this. Once again, solid dot to represent that we are including the 4, open circle to indicate that we are not including the -3. So here are your answers here. Let's see if I can sneak number 8 underneath this. Make sure we're in frame here. We are. So number 8 is an absolute value equation. And my first goal is to get the absolute value by itself on one side first. So I'm going to do that by adding a 5. And then dividing by 3. Don't try to distribute things in, especially if that's a negative in front. That'll really mess things up. So this gives me the absolute value of 4x plus 3 is equal to 10. Now, what that's going to do is that's going to split this up into 2 pieces. 4x plus 3 equals 10, or negative 4x plus 3 equals 10. Some teachers have the negative, they put it over there. I teach my students to do it this way. And I'm going to solve each one and I'll get my 2 answers. Subtract the 3 off and divide by 4. There's one solution. For this side, I'm going to distribute the -1. Notice it changes both signs. They were both positive originally, now they're both negative. Divide both sides by -4. And here are my 2 answers. Now, I want to warn you, some students, they just do the one side. They don't even bother doing the other side. The other side, it's critical that you show that because that shows that you understand the absolute value, that there are two potential answers usually. All right, that is number 8. Moving on to number 9. All right, let's bring that up. And this is an absolute value inequality. Now this is a less than case, what I call type 1 in my class. When it's a less than case like this, we actually take whatever that number is, we make it negative, put all that in the middle, and then 1. So we have a -1 and a +1 surrounded. And now what we're going to do is we're going to get that x in the middle by itself. Like with the other problem that we had, if I subtract 6 here, I have to do it here and here. Next up, to get the x by itself, I need to divide by 4. Then I have to do it everywhere. In this particular problem, you're asked to write it in interval notation, which I will do here in a moment. Interval notation, because there's no equals to symbol, it's in parentheses, or both. There is your final answer. Now this is in contrast to the type 2, which is going to be number 10, which is absolute value of x plus 7 is bigger than 2. So this one we had a less than, and we got to break it into the 2 pieces. Bigger than, we can't do that. We have to just kind of grind it out. So this is going to be x plus 7 is bigger than 2, or negative x plus 7 is bigger than 2. Some teachers or tutors might tell you to just write it again, but switch and then change the sign. That's because of that negative. Now you know where that comes from by the definition of an absolute value. And then we're going to solve each one. Notice when you distribute the -1, both signs change. They started out both positive, now they're both negative. Yep, made that a little too long there. Now notice I'm dividing by negative. This is x is now less than -9. And they want this answer as an interval as well. I'm going to draw the graph. You don't have to draw the graph if it doesn't say so, but sometimes that's a good visual. So less than -9, not including, looks like that. Bigger than -5, not including, looks like that. Now, if you remember, we have that no man's land there, that gap. And so the way we want this to read is -infinity to -9, or -5 to infinity. And the way we represent or in math, this is going to look like this. -infinity to -9. We use the union symbol. -5 to infinity. That is interval notation. And again, that union symbol represents the word or. For this next one, it's actually a word problem, and I want to share my screen with you. This is actually our last problem. And let me share my screen with you real quick. I know word problems can seem scary, but a little bigger. There we go. We have two cyclists that are 60 miles apart, start riding toward each other at the same time. One cycle is 2 times as fast as the other. If they meet 2 hours later, what is the speed of the faster cyclist? And then they want us to write an equation as well as solve it. So we will do that. They also ask us to use the variable r to represent the speed of the slower cyclist. So feel free to take a screenshot of that if you'd like, but I am gonna go back to my other camera. All right, so I'm gonna draw a picture of what I'm seeing. So here we'll have the slower cyclist. Here we'll have the faster. And they're gonna meet here. I wanna point out that they start out 60 miles apart. Please note, neither of these cyclists are going 60 miles. They're both going a part of that 60 miles. Because if I take the distance that the slower person went and add that to the distance of the faster person, then I should have the full 60 miles here. As they indicate, I'm gonna let R represent speed of the slower cyclist. And the problem says that the faster one is actually going 2 times as fast as the other. But 2r is going to represent the speed of the faster cyclist. And I like using a table. And we, of course, are going to be using our old friend, rate times time is distance. So I'd like to point out that the rate of the slower is right here. R is what we called that. The rate of the faster cyclist is 2r. And in the problem, it says that it takes them 2 hours until they meet. Now you may think to yourself, what's the distance? Well, you may think that it's 60 miles, and it's not. They're both going a portion of that, which is where our formula comes in. So I'm going to actually do rate times time to represent distance. So in this case, 2r. Rate times time in this case is going to be 4r. 4r and 2r are the two distances that each of these cyclists are going. Now, you can see if I take the distance, 2r, that the slower cyclist went, and I add that to the distance that the faster cyclist went, 4r, that should be a total of 60 miles. There's my equation. Now to solve this equation, I'm going to combine up my like terms and then solve for r. Now the question wants to know, what is the speed of the faster cyclist? You'll note R is the speed of the slower cyclist. So I'm not quite done. So if I want to find the speed of the faster cyclist, I'm just going to double that. So what's the speed of the faster cyclist? 20 miles per hour. And recall, again, this is the slower, this is the faster. And that is that. Thanks for tuning in. I appreciate it.